welcome back to this tutorial on distributions. So previously we saw two data sets. So one was coming from a Poisson distribution and the other was coming from a normal distribution. So right now we have another challenge. We have a data set. We'll have to, as usual, guess the distribution, do the visual inspection, and then finally do the statistical tests. So without any further delay, let me show you the data that we have. So as usual, one column, and this time we have around 51 observations. And the data seems to be coming from a continuous random variable. So we have 51 points. As usual, let's load it to Python and then see what we can do. Importing pandas numpy, reading the Excel file, printing the data frame. So 50 points. Let's do the histogram. Wow.
Okay. So the histogram, you have one peak and peaks on the either side, but it is not symmetric in nature, right? So you have what symmetric in the sense there is no stepwise decrease. It is across the center, you have values on both sides, but there's no stepwise decrease. There's just a center point, then something on the side. So what you can basically say is, again, non-Gaussian, symmetric, somewhat symmetric, but can we conclude something about it? Nothing more. We can only say that it is somewhat symmetric in nature and it's non-Gaussian in nature. So it could be anything. It could be a Poisson, it could be a uniform, it could be some other distributions, so on and so forth. Yeah, so that is all we can do from this particular histogram.
Very true, very true. So as
you have
first
to be,
okay, till now we haven't guessed anything. We do not have enough evidence to make a guess. So let's take a look at the descriptive statistics. So the mean seems to be 54.92 and the standard deviation seems to be pretty low, 2.65. Interesting. And median is also 54, that is close to the mean. And this seems to be I mean, look at the minimum value and maximum value. It's ranging between 50 to 59, right? So this gives us some clue.
Yeah. So here, more than the minimum and maximum value, what we should actually see is between the minimum and 25, 25 and 50, 50 and 75, 75 and maximum, those intervals, if you see, it's all just around 2.
Yeah.
Right? And one more thing is that we have a mean value and the standard deviation or the variance is around 5. The mean is something, the variance is very, very small. Our standard deviation is very, very small and it is symmetric. So we were originally wondering it's a symmetric distribution, but it's non-Gaussian. So it could be some, but if from a sample, we can't completely conclude whether it's Poisson or let's say uniform. But from these numbers, you can actually confirm that it is uniform.
Uniform, yes.
So because between the quantiles, the split is almost same, and the mean and the in fact, more than the mean, the standard deviation is very, very small. So with the histogram and the descriptive statistics, in this particular case, we can say, okay, this comes from a near uniform distribution. Uniform distribution would be the best guess at this particular point.
Very interesting. So let's also look at the skewness and kurtosis.
Okay. The kurtosis is negative. So what that does mean, Swami?
I mean, so we don't have any concrete evidence about this. So generally for normal distribution, the kurtosis would be around 3.
Correct.
Lesser than 3, I think.
It cannot be a normal. Correct?
Yes.
So the kurtosis is negative. That is also reinforcing our judgment that it is not a Gaussian distribution. The mean 54. The variance is only 7. And the skewness is 0.18.
Very, very low. Skewness is 0.18.
Yeah. So it is not skewed to either side. It is centered. And the variance is very small. So we can actually say, okay, so, and looking at the split across quantiles, which is also almost even, very low variance, good mean. So we can say that, and the minimum and maximum. So 50 plus, let's say 59.69. So let's assume to be 60. So 50 plus 60 by 2. is 55. So 55 and the mean of 54. So we can assume that this comes from a uniform which is between 50 and 60.
Yeah, looks like a solid guess. Let's see. So as usual, importing certain packages, and then we are heading towards QQ and PP plot. So that's the QQ plot.
Okay. In fact, show the PP plot as well. At this point, once we are in the third tutorial, we can actually discuss both together.
Sure.
Yeah. So PP and QQ, again, it's comparing the sample with a theorized uniform distribution. That is why you have dist is equal to uniform, and it's an almost straight line. You can't expect anything more. So we can say, okay, our guess is correct. It's a uniform distribution.
All right. So now, as usual, we'll formulate the null and alternate hypothesis. Null hypothesis says that the given data follows uniform distribution, and the alternate hypothesis says that the given data does not follow uniform distribution. And so, as you all know, the mean here is 54.92. Therefore, I'm using that information here. I'm creating a new column in the data frame called df of expected, and I'm storing the mean value there. So now if you look at the data frame, so we have two columns. Column 1 is the observed value. Column 2 is the expected value, which is nothing but the mean, right? Which is, as Malolan explained, it is the upper value plus lower value divided by 2. So now directly let's get into the chi-square statistic. So chi-square of the observed values and the expected values. All right, so we have a chi-square statistic of 6.311 and p-value of 0.99999.
Right.
So that's huge.
So that's huge. Yeah. So our null hypothesis is not rejected. So we say that it is something, it is coming from a uniform distribution. We can stick to it. And now the chi-square statistic is alpha and your number of degrees of freedom. So what is that going to be?
So k minus p minus 1. So for p, the p for uniform distribution is 0 because there is no parameter. So you have the lower bound and upper bound. So it is nothing but k minus 1, which means 50 minus 1, that is 49.
49. So we just put that there. 66. So our test statistic is lower than our chi-squared statistic number from the tables. So we can say that we do not reject the null hypothesis, and we will say that this distribution, this data is coming from a uniform distribution. And for those who are wondering what could be uniform in nature, let's say any event that has a probability of happening. Let's say you're throwing a die. It has 6 faces, right? So a number can happen with either 0 or 1 by 6. So that's a uniform distribution. So any event of that nature would be having a uniform distribution.
Very true. So the other example that I could think of is the fuel efficiency. For example, you put 1 liter petrol or 1 liter diesel. So every time you will get a different mileage. It could be 50, 52, 47. In case you're driving rash, it will be very low, say 40, 42.
I hope these numbers are for 2-wheelers. If you have such a car, let me know. I will buy it.
Electric vehicles are on the way. So we hope we'll get better mileages. So with this, we'll conclude this tutorial on distributions.
Exactly.
And hope to see you soon in another lecture.
Yeah. Have a nice day. See you guys. Bye-bye.